Hello. Today we will be looking at powers and roots of complex numbers, which is section 7.5. And hello, this is Mrs. Johnson. We will begin with De Morbay's theorem, or you could refer to it as a formula for finding powers of complex numbers in trigonometric form. So, this formula tells you if you have a complex number in trigonometric form, then to raise that number to a power, your power becomes the exponent for r, and it is also, that power is also multiplied by your angle measurements. And of course, n represents the power, it represents the exponent. All of our objectives are in Moodle. However, objectives for this lesson. Looking at an example of using De Morbay's theorem to raise a complex number form to a power. As you can see, we are asked to raise this number in trigonometric form to the fifth power. That means, to do so, our r value of 2 must be raised to the fifth power. 2 to the fifth power equals 32. 2 times 2 is 5 times is 32. And to finish it up, our angle measurement must also be multiplied by our exponent, our n value of 5. So 45 degrees times 5 gives us 225 degrees. Now just simplifying by evaluating our trig portion. Common angle here, the cosine of 225 degrees is negative square root 3 over 2. Likewise, the sine of 225 degrees is negative square root 2 over 2. We bring down the plus sign and the I. And then to finish simplifying and finish the problem, we must distribute. So, a positive times a negative, which is the case with both numbers inside the parentheses, will give us negative answers. So we've taken care of our signs. When we distribute, you can cross cancel each time. 2 divides into itself in 1, so we do not have to write a denominator 1. That's why we don't see a denominator in the next line in our final answer. And 2 divides into 32 16 times. So 32 times negative square root 2 over 2 equals negative 16 times the square root of 2. And of course, you're multiplying the same exact numbers again when you finish your distributing. So you get the same answer, negative 16 times the square root of 2. Of course, over here also times I. And this problem is complete. Our next example asks us to find the root of a complex number. This is almost identical to how you would find, or in fact it is identical to how you would find a root with arithmetic. So you are given that negative square root of 3 plus I to the 8th power equals negative 128 plus 128I times the square root of 3. Again, all of this is given to you. Given this, you are asked, what is the 8th root of negative 128 plus 128I times the square root of 3? So being asked for the 8th root is the same as being asked what times itself 8 times will give this answer. When we look at the original, what was given to us, the original problem, it's clearly telling us that negative square root of 3 plus I is being multiplied times itself 8 times and giving us this answer. Therefore, the 8th root of negative 128 plus 128I times the square root of 3 is negative square root of 3 plus I. Lastly, in this video lesson, looking at finding the roots of complex numbers. To find the root of complex numbers, your number will need to be in trigonometric form. It could be given to you in that form, or you could convert it from complex form to trigonometric form. Of course, we covered that conversion in the previous section, so please feel free to refer back to the notes and video lessons for that section, your textbook for that section, if you need to review that. Well, we have another theorem. A theorem in math is just something that's proven to be true. In other words, it always works in this situation, but you could also refer to it as a formula. This theorem or formula says if you are given a complex number in trigonometric form, it has roots given by this formula. In other words, you can find the roots using this formula. In this formula, n is your exponent. Pi is the angle 180 degrees. So you will always plug in 180 degrees for pi. If you think back to our first chapter, there we learned, or we were reminded, that 180 degrees is equivalent to pi radian. Theta is always your angle measurement, and K must be substituted with the values 0, 1, 2, 3, 4, and so forth in numerical order until the request number of roots are found. Only one number can be substituted for K at a time. And we will see this, how to do this in the next problem. We'll see this in action. So we're asked to find the cube root of 8 times the quantity cosine 30 degrees plus I sine 30 degrees. So we're asked to find the cube root, meaning we have to find 3 roots of this number that is already in trigonometric form for us. So again, you're going to have 3 answers because you're asked to find the cube root. Each root must be found individually. That means you're going to plug into this formula 3 different times and simplify to get all 3 of your answers. Since we have to plug into it 3 times, going back to the previous slide, you can see we always start with 0. We will be plugging in 0 for K the first time, getting an answer, working the problem again, plugging in 1 for K, getting our second root, and then lastly, plugging in 2 for K and getting our third root. Going ahead and doing so, going in order, first plugging in or substituting 0 for K. So as you can see where K is located in both numerators, K has been replaced with 0. Pi, we know we plug in 180 degrees for pi. So for both locations of pi, we see that pi has been replaced with 180 degrees in the numerator. We've substituted for K and pi in both numerators. Keep the plus sign and the 2. And in place of theta, we write our angle measurement. Looking back at the original problem, we see that our angle measurement is 30 degrees in the original problem. Okay. The last thing we need to substitute for is n. N is in our formula 3 times. And so in place of n, we have to put how many roots we're finding. This time it's 3 roots. So everywhere n is located, we replace it with 3, which is in our exponent and in both denominators. That's just simplifying. 8 to the 1/3 power means the cube root of 8. So what number times itself 3 times will give you 8? And that number is 2. 2 times 2 is 4, and 4 times 2 is 8. So 8 to the 1/3 power is 2. Now simplifying inside the parentheses using the order operation. Multiplication first in the numerator. We must get an answer for the numerator before we can work with the denominator or work with both. So 180 times 0 times 2 is 0, plus 30 degrees gives us 30 degrees. Copying the denominator, and 30 degrees divided by 3, of course, gives us 10 degrees. Same identical problem in our second parenthesis. It's going to give us the same answer. Bringing down everything else, and we have our first root. This root again was achieved by plugging in 0 for k and simplifying. We repeat the process to find our other roots, but of course, we found the first one, finding the second one rather than plugging in 0 for k. We must substitute 1 for k. Still pi is 180 degrees, plus 2 comes from the formula. Theta angle measurement is 30 degrees because 30 degrees was given to us as our angle in the original problem. Our goal is still to find a total of 3 roots, so still for n, everywhere n is present, we need to put 3. Again, we simplify as usual, simplifying our numerator by doing multiplication, then addition, the order operation, and dividing that answer by 3. So 360, the answer for multiplication, plus 30 gives us 390. Divided by 3 tells us that we have 130 degrees. 8 to the 1/3 power, again, just the cube root of 8, that is 2. And we have finished the problem as well as finding the second root. And finally, to get the third and final answer, you go through the formula again, plug it in, and simplifying. But the last time we plugged in 0 for k, 1 for k. We have to find 3 roots. So after 0 and 1, we move to the next number. This time we plug in 2 for k. Still always 180 degrees for pi. The 2 and the plus sign comes from the formula, just copy it. Again, your angle is always that angle given to you in your original problem, in your original number. So that angle was 30 degrees. We're finding the third root. So n is 3. Simplify just like you did the first and second time. And this time for our final root, since we were asked to find 3, we have it here. 2 times the quantity cosine 250 degrees plus I sine 250 degrees.